show you how to plot a polar curve. So the first thing that we need to do is we need to switch from Cartesian coordinate system into a polar plane. To do that, you navigate to this button right here, click on that, and you will see there is two options. One is the Cartesian grid or rectangular grid, and the other one is the polar plane. You click on that and you see the polar plane appear on your screen. As I mentioned in the lecture, there's many fancy graphs that you can draw using equations in polar coordinate system. So what I'm going to do is I'm going to draw some polar curves such as the circle, the cardioid, the rose curve. So for the circle, I'm going to try r equal to 2 times cosine of theta, which is the equation, polar equation shown in example 6 in the lecture notes. So the equation again is r equal to 2 times cosine of theta. So what you see is what you're going to type in here. So r equal to 2 times cosine of theta. So the angle has to be theta. You cannot choose any other letter, and theta has to be restricted at a certain interval. In this case, for the circle, with the polar equations, r equal to 2 times cosine of theta, theta has to be between 0 and pi. And of course, you can change that to something else, 0 to 2 pi, 0 to 3 pi, so on and so forth. It's just that we're going to let the circle go in around and around forever. So just restrict theta here in this case from 0 to pi. So usually the circle in Cartesian's coordinate, the angle is between 0 and 2 pi. But in this case, the setup for the polar curve r equal to 2 times cosine of theta, because you already have the 2 in front of it, so theta has to be between 0 and pi. I'm going to try something else here. I'm going to draw the rose curve. So the setup is very similar. It's just that the angle of cosine will change a little bit here. Cosine with 1 theta. I'm going to change that to 3 theta. As you can see there, this is considered to be rose curve for n petals, or 3 petals in this case. Or you change this to 5, so you have 5 petals. 7, you have 7 petals. So for the odd number of theta, you're going to have the odd number of petals. Similarly, you can try with some other curves such as r equal to 2 times sine of theta. And as you can see, this is also a circle, and I'm going to restrict theta from 0 to pi. I'm going to change the number of theta. Instead of just 1 theta, I'm going to change that to 2 theta, or 3 theta, 4 theta, 5 theta, 6 theta, so on and so forth. So you can do whatever you like with this type of curve. I'm going to try one more here for good measure. This is going to be the cardioid polar curve. And the equations of that, again, you can find this information in the lecture notes. That is r equal to 1 plus 2 times cosine of theta. For theta, let's say between 0 and 2 pi. Okay, so this is the cardioid. You can manipulate the value of A and the value of B. For A is this number, and B is the number in front of cosine of theta, right? Or the coefficients of cosine of theta. You can see the same behavior for sine of theta. When you change to sine of theta, is kind of switched to the vertical axis again, because sine corresponding with the vertical axis and cosine corresponding to the horizontal axis. Again, you can manipulate the value of A, which is the number by itself. I change this to 2 here. You can change to 3, 4, so on and so forth. So let me go back to 2 here. I'm going to change this one to 1, then 3, 4, 5. Okay, so whatever you want to show, whatever purpose that you want to use this type of curve, you can manipulate the constants to have a different shape. Okay, so that's it for the graph of polar curves. Very straightforward. Instead of doing everything by hand, there are some tools at this point in our lifetime to just actually plot out polar curves. That's it for me. Let me know if you have any questions. Thank you.